Hello everyone, I am Mrs. N. Thangamani, Assistant Professor, Department of Chemistry. I am working in Trinity College for Women, Namakkal. Now I am going to talk about nanochemistry. What is meant by nanochemistry? How do stain resistant material work? And how do electronics keep getting smaller? Is it possible for cancer patients not to have side effects? Dear friends, any guess? The answer is nanotechnology. Nanotechnology makes it possible. Then what is meant by nanotechnology? Nano means very small. That is 1 billionth. The range is 10 power minus 9 meter. Nanometer. The symbol of nanometer is small letter nm. 1 billionth of a meter is said to be 1 nanometer. Scientific terms, it can be explained by comparing our human hairs. A human hair is 10,000 nanometer wide. Just think how little the nanoscale. A human hair is 10,000 nanometer wide. Now let us see the definition for nanotechnology. A field of applied science focused on design, formation, identification and application of materials and devices on the nanoscale. Two methods of making nanoparticles. The first one is top down, the second one is bottom up. That is top down versus bottom up. Top down. Cut object smaller and smaller until attain size needed. That is said to be top down. Bottom up. Add atoms together one by one to attain correct property. That is said to be bottom up. We just compare top down versus bottom up. Then now let us see the properties that can change at the nanometer scale. That is, what are the properties mainly change the nanometer scale? There are mainly 4 properties. The first one is thermal, second one is mechanical, third one is electrical and fourth one is optical. Thermal. What is mean by thermal? Melting temperatures. Mechanical property is adhesion, that is stickiness. Electrical property is current. Last one, optical property means prisms. These are the 4 main properties that affect the nanometer scale. Visible light is electromagnetic radiation. There are number of rays present in electromagnetic radiation. Now we see only the visible light. Our visible light means white light. This white light contains 7 different colors. The colors should be, the white color is all visible colors together which have a wavelength between 740 nanometers to 380 nanometer. There are 7 important prime colors are available. Shortly, these colors are said to be VIBGR. That means V means violet in color, I means indigo in color, B means blue in color, G means green in color, Y means yellow in color, O means orange in color and R means red in color. That is VIBGR, violet to red color. That is In longer wavelength, we see the red color. In shorter wavelength, we see the violet color. Our electromagnetic radiation contains these 7 colors in visible range. Now we are going to see the wavelengths of spectral colors. We see 7 colors and each color responsible for particular wavelength range. Now we are going to see the colors and their wavelength range in nanometer scale. First one, red color 740 nanometer to 625 nanometer. Orange color 625 nanometer to 590 nanometer. Yellow color 590 nanometer to 565 nanometer. Green color 565 nanometer to 520 nanometer. Cyan color 520 nanometer to 500 nanometer. Blue color 500 nanometer to 435 nanometer. Violet color 435 nanometer to 380 nanometer. That is our color range, wavelength range in nanometer scale starts from 740 nanometer in the red end and it completes in 380 nanometer in violet end. These are the spectral colors which contains in white light. Let us see what are the optical properties are mainly directly dependent on size. For example, we just compare gold and silver nanoparticles. Cut to 1000 nanometer, the color would be golden color. Then we cut to 700 nanometer, the color would be red. Cut to 600 nanometer, the color would be orange. The color changes because each color has a specific wavelength. For example, we just compare only gold and silver nanoparticles. Optical properties of gold and silver nanoparticles. First one, silver nanoprisms wavelength range is 100 nanometer. Gold sphere wavelength approximately 100 nanometer. Gold sphere approximately 50 nanometer. Silver sphere approximately 120 nanometer. Silver spheres approximately 80 nanometer. But both silver sphere are different in their color. The last one is silver sphere approximately 40 nanometer. These are the optical properties are directly depend the size of the nanoparticles. We just compare silver and gold nanoparticles with different sizes. What are the future uses and possibilities for nanotechnology are endless. That is, nanotechnology is a advanced science technology. Imagine a soldier that has a uniform that can change from desert to winter to forest, camouflage by using current from a small battery to rearrange alignment of the molecules. We just compare the uniform of soldier in different types of places. We can just change their color by changing the size of the molecules. That means molecule levels. One single line we explain the term of nanotechnology. That means the path to a better and more efficient for future. There are four important things. First one is jobs, second one is technology, third one is entertainment, and the last is health. So in our future we just use nanotechnology for our bright future. Thank you for watching.